Okay, so this just looks like a mess here. It's called squaring binomials and factoring perfect square trinomials, which when you look at it, you just think, what in the world is all that? Well, let's see if we can kind of take this apart a little bit. First of all, a binomial is just a statement that's got two terms in it. So x plus 5 is a binomial, and 3x minus 2 is a binomial, and even 5x squared plus 6x is a binomial. It just means it's got two terms. Bi means two, num means number, so it's got two numbers, two terms, and so that's all we mean by it. So let's now that we've taken care of that, let's see what we're going to do here. We're going to be squaring them and then factoring perfect square trinomials. Trinomial just means it's got three terms. And here's what's going to go on. When we get done squaring a binomial, we will have a perfect square trinomial. Perfect square trinomial. So we'll be basically squaring binomials, getting a perfect square trinomial, and then factoring it back to this. So that's all we're doing. So let me give you an example. So here is a very simple binomial, and we're going to square it. Okay? Now, I'll be honest with you, it's very tempting to write x squared plus 5 squared, or 25, and that looks great. The problem is it's wrong. Okay? So let me just take care of that right now. You can't just square this and square that and call it good. There's no distributive property of squaring. What you can do, though, is write it this way. X plus 5 and x plus 5. That's x plus 5 squared, because squared means multiply it by itself. Now we're just going to FOIL. So let's do this thing. X squared times x, x times x is x squared. I'm going to do this in your head. X times 5 is 5x, and 5 times x is another 5x, so we're just going to write that as 10x. And then the last term, 5 times 5 is plus 25. Okay? And we're done. We've taken a squared binomial and written it as a perfect square trinomial. Okay? So we're going to do that again with a couple other ones. Let's write p minus 7 squared. Okay? That's p minus 7 times p minus 7. And now we'll FOIL. P times p is p squared. P times negative 7 is negative 7p. You get another negative 7p here, because of doing the inside. You get negative 14p, or minus 14p. And then negative 7 times negative 7 is plus 49. Let's do another one. G plus 7. Let's make it something different. G plus 6 squared. You're going to get G plus 6 times G plus 6. And then we'll FOIL. G times G is G squared. You're going to get a plus 6G and another plus 6G, so plus 12G. And then plus 6 times 6 is 36. Now, eventually you may get to where you say, look, I think I can just do these in my head. Okay? Because every time you do one of these, let's write a new one here. X plus 4 squared. Okay? You'll always seem to get this thing squared at the beginning and this thing squared at the end. So here's p squared. Here's negative 7, here's positive 49. Here's an x squared. Here's a 5, here's a 5 squared. Okay, so we could probably just say, look, it's going to have an x squared here, and it's going to end in plus 16 out the back door. So x squared is x squared, and then 4 squared is 16. And then this thing right here, the thing in the middle, is always two of these. Okay, notice that? Here's 12g. Here's 6. Okay, here's negative 14. Here's negative 7. Here's 10. Here's 5. Okay, so we could probably say, look, it looks like the middle term here is going to be plus 8x. And if we were to write this thing out this way, we could FOIL it and check. X times x is x squared. X times 4 is 4x. Here's another 4x, so there's your 8x. And then 4 times 4 is 16. So it worked. So let's get a new screen here. Let's do another one here. Let's go t minus 11 squared. We know we're going to get t squared. We know that out the back end we're going to have plus 121 because that's negative 11 squared. Okay? And then this middle one right here is going to be negative 22 t because it's always two of these. Okay? So we've gotten to where we can do these things out without having to bother foiling. Let's go r plus 9 squared. Going to be easy. R squared. Two of these is going to be 18r. And that squared is going to be 81. Let's do another one. M minus, why not, 10. Okay? M squared. Two of these is going to be negative 20m. And this squared is going to be plus 100. And we're done. Okay? Well, we've taken care of one of the skills here. We were planning on learning how to square a binomial, squaring binomials. Okay? And then we're going to factor perfect square trinomials. In other words, we're going to be going from here backwards. Okay? So let's do one on a new page here. Let's get f plus, I don't know, 7 squared. We know we're going to get f squared plus 14f plus 49. Okay? And our job would be, if we didn't know this, we'd have to be able to start here and go backwards. Okay? Well, one option is to say, look, let's factor this thing like we did in previous videos where we're factoring. You take the last number, 49, write out all the factor pairs. In this case, it's 1 and 49 and 7 and 7. We're going to be looking for a pair that adds together to get 14. Well, that's that one. Okay? So it's pretty clear we would have f and f, and then our middle numbers are going to be 7 and 7. And they need to add together to get positive 14, so plus. Well, that confirms that we got this thing here. Okay? So basically what we're doing is factoring like we did before, but you know, I'll bet we can notice a pattern here. Okay? Let's look back at our original page here. If I hadn't known these things over here, okay, I could look and say, well, you know, I know it's going to be, at the very beginning, we're going to have an x because they had x squared here. At the end, I'm going to have 5 because that's got to be 5 squared has got to give you 25. Okay? And then over here, p, because we have p squared over here, we're going to have p. Because we had a 49, we're going to have a 7. It's going to have to be a negative 7 because these things add together to get negative 14. Okay? So here's what I'm noticing. If this thing is a perfect square, like one of these things here, the term at the beginning is just whatever this is square rooted. The term at the end is whatever this is square rooted. And we've got to make sure that that they add together to get this. So we need positive 4 to get positive 8. We needed positive 6 to get positive 12. We needed negative 7 to get negative 14. So let's do a new one here. Let's start with g squared minus 12g plus 36. Okay, so here we go. We're going to have a g because we've got g squared there. We're going to have a 6 because we've got 36 there. And then because they have to add together to get negative 12, we're going to need a minus. Okay? Put a square in there and we're done. Okay? Now, how about something like this? G squared, now that's going to be a different variable, t squared plus 8t plus 12. Okay? Now let's make this plus 64. Okay? Well, it looks like this is going to be t in here from the t squared. It's going to be 8 there. Okay? We're going to have a squared, and it's supposed to be positive, so we're going to plus. But the problem is, if you multiply this one back out, you don't get back to here, because that 8t actually should have been a 16. Okay? So I tricked you a little bit there. This one didn't work because this one's not a perfect square trinomial. Okay? Here's how I knew that. In order to be a perfect square trinomial, I need to get the same thing if I square root this as if I cut that in half. Okay? What do you mean by that? Well, If I square root 36, I get 6, and if I cut this in half, I get 6. Another way I like to put it is, if you cut this in half and square it, you better get this. Let's check that with the other ones. If you cut that in half and square it, you get this. Yep. If you cut that in half and square it, you get that. If you cut this in half and square it, you get that. Okay? If you cut that and square it in half, you get that. So that's how you know it's a perfect square trinomial. So if you get one of these things and it's not a perfect square trinomial, it's not going to factor out into something nice squared. Okay? So the only ones we're doing this way is if we have t squared plus, let's go ahead and go with 8t plus 16. Before we try to write it this way, we better check, is it a perfect square trinomial? Well, half of that is 4. Square that, you get 16. Okay? So it worked. So we should be able to write t from the t squared, 4 from the 16, and because it has to add together to get positive 8, we'll write it like that. So you've now seen how to take a squared binomial and write it as a perfect square trinomial, and how to take a perfect square trinomial and write it as a squared binomial. Okay, that's it.